This video is about waves. We're going to talk about the two different types of waves and then do some math problems at the end. So first, waves in general. Waves are rhythmic disturbances that carry energy, okay? So if I ask you what they carry, you need to make sure that you know they carry energy through both matter or space. A medium, and it's a vocab word there, is the material which the wave transfers energy through. So if you're trying to talk underwater to somebody, the medium would be the water. If you're talking, like right now, me talking, the medium is the air. Okay? So the medium is the material that the wave is transferring through. Okay? Now the first type of wave is called a transverse wave. Okay? Transverse wave. This means that the medium moves perpendicular to the direction of the wave motion. So what it means, the wave is going this way, but the material is actually going up and down. Okay? So the wave is going that way, but the material itself is just simply going up and down. This point right here just goes up and down as the wave moves along the material. Okay, so this is like a rope. If you were to do a rope like this, if you go really back and forth really fast, this piece of the rope is just going to stay there. It's just going to go up and down. The rope, though, the wave on the rope will go side to side. Okay? So transverse wave, perpendicular, simply means one's going that way, one is going that way. Okay? Now here is what's called wave anatomy. It's the parts of the wave. You've got to make sure you know every little piece that I'm about to show you. So let's talk about first, this line here is called your origin. Okay? So this line there, the line that's going down the middle, is your origin. Alright, so it's in the middle of the wave itself. The very highest points of the wave, here and here, the very highest points of the wave are called your crests. Highest point of the wave is crest. Here, the lowest point of the wave is called a trough. So these are your troughs. Alright, next vocabulary word. From here to here, these guys, so you have the highest points are called crests, the lowest points are called troughs, and then the points in the middle are called nodes. Okay? Now, let's talk about length of things. When you go from one crest to another crest, this is called the wave length. It is the length of one wave. Now, wavelength can actually be measured in several different places. So it can be from crest to crest, it can be from trough to trough, it can be from one part of the wave to the exact same other part of the wave. So we're coming up here, so you're going to go to the next part where it comes up. So this is also a wave length. Okay, now let's talk about the height of the wave. When you go from the origin to the trough, this is called amplitude. The amplitude, okay, the wavelength tells you how long the wave is. Amplitude tells you the energy of the wave. The higher the amplitude, the more energy it carries. All right? Now, so it can go from origin to the trough, or it can go from origin to the crest, because remember, the origin should be in the middle of the wave. So these two values should be the exact same thing. Okay, you should be able to label everything that I have up here on your own without looking at your notes. So that would be something that you need to study. Okay, now the next type of wave is a longitudinal wave. Okay, longitudinal wave, also known as a compressional wave. The reason it's called a compressional wave is it literally has compressions within it, just like a slinky. If you had a slinky and you balled it up and let go, that would be the compression. This is where it's let go. Okay, the medium moves in the same direction as the wave motion. So this material is going to go that way, and the wave is going to go that way as well. So this is just a picture of showing, you should see the little compressions here, little compressions, and then you have your parts where they're not compressed. An example of this is sound. This is exactly how my voice is getting to your ears, because all it's doing is moving particles along, just like that. Okay, I know it's kind of hard to see on here, but this is also just labeling the parts. You should be able to label the parts just like we did before. Where it's tight together, that is called a compression. Where it's tight together is called the compression. Where it's not tight, where you have space in between, is called a rarefaction. Rarefaction. The wavelength, all it does is include one compression and one rarefaction. Okay, so the length of one compression and one rarefaction is called a wavelength. So it can be from here to here, or it can be from there to there. Now, the amount of compression corresponds to the amplitude. It's the same thing. So this amount of one compression is called its amplitude. Okay, this is just showing you, again, how that energy relates. Okay. Some more vocabulary. Frequency is the number of waves passing per 1 second. Number of waves per second. Its units are in hertz. The shorter the wavelength, the higher the frequency, the higher the energy. Okay, that's going to be essential to know for this unit. So shorter the wavelength, higher the frequency, higher the energy. So let's look at these two, for example. This is called a wave train. Just means you have a lot of waves going on within the unit that we're looking at. So if this is 1 second, to figure out frequency, all you would do is count the number of waves per that 1 second. So how many waves does this have? So you go from one part of the wave to the exact same other part. So here to here, so that's 1 wave, 2 waves. So this has 2 waves per second. So it is going at, it has a frequency of 2 hertz. This one, 1 wave, 2, 3. So this is 3 hertz because it has 3 waves per 1 second. So what this means is this has the higher frequency, but if you notice, because it has a higher frequency, what has happened to that wavelength? The wavelength has gotten shorter. So that's what this is saying. Higher frequency, shorter wavelength. Okay, so the one formula for this unit is going to be this. V equals frequency times wavelength. Wavelength has this funky little symbol going on, but it's the same, it's wavelength, okay? V is velocity, is simply the speed of the wave as it moves forward. It depends on the wave type and the medium. The only thing that can change the velocity of a wave is the medium that it's traveling through. The velocity of a wave is equal to frequency times wavelength. So you get this V equals F times wavelength. Now you know you've got to know your units for things, so this is what's saying. V is velocity, F is frequency, the upside down Y thing is wavelength. Velocity is meters per second, frequency is hertz, wavelength is meters. So then if we go and do our thing that we always do with equations, our triangle, V is already by itself, so it's going to go on top with frequency and wavelength on the bottom. Okay, so let's do some examples. Find the velocity, so it says find the velocity of a wave pool if its wavelength is 3.2 meters. So meters means this is our wavelength. Hertz is always going to be frequency. You're trying to find velocity, so you shade in velocity. So all you're going to do is frequency times wavelength. So you're going to do 0.6 times 3.2. Which gives you 1.92 meters per second. Okay, one more example. An earthquake produces a wave that has a wavelength of 417 meters. Meters, and it says wavelength right there. So this is wavelength. Travels at 5,000 meters per second. Meters per second is velocity. What is its frequency? So you're trying to find F. So here we go. We're going to shade in the F, and whatever is left, that is what you're going to plug in. So F is just equals velocity over wavelength. So 5,000 divided by 417, which gives you 12. And the units for frequency is hertz.